Hello, my name is Tristan Dean. Today we're going to be covering Chapter 1 of the Fortey Studies textbook. Chapter is titled Biology and Human Behavior. Okay, so this chapter is actually composed of about 4 studies. The first one being One Brain or Two by Michael S. Gazzaniga and Roger W. Sperry. And the reason it was done was to understand whether the two hemispheres of the brain function independently after the corpus callosum is severed. Think of that as the connection port between the two sides of your brain. The theory or hypothesis they were working with was that each hemisphere has its own specialized abilities, and that separating them would reveal their quote-unquote independent minds. The pair went on to study split-brain patients who underwent surgery to reduce epilepsy, as well as use a variety of tests, visual, tactile, and auditory, sent information to only one hemisphere. In the end, they found that the left hemisphere controlled speech, logic, and naming objects, while the right handled spatial tasks such as recognition and emotions, but could not verbally describe experiences. This was and is an incredible achievement. The pair were able to show that the two hemispheres of the brain have distinct but complementary functions, and they revolutionized the understanding of brain lateralization. Or brain function, as I understand it. It's a big word. We're going to speed it up a bit now. More experienced, bigger brain, study number 2. This was done by Mark Richard Rosenwig, Edward L. Bennett, and Marianne Cleaves Diamond. The reason the study was done was to determine if environment and experience physically change the brain. Their hypothesis was that rats raised in enriched environments would develop larger, more complex brains than those in impoverished settings. The way they tested this was they ran 16 experiments with rats raised in 3 different conditions. They had one standard cage with a colony, one enriched cage with toys, activities, and other rats, and one impoverished cage that was isolated with no toys. After that, they examined brain weight, cortex thickness, and neurochemistry of each of the rats. They found that the rats in enriched cages had thicker cerebral cortexes, more dendritic branching, and higher neurotransmitter activity. The isolated rats, however, had the least brain development. This study demonstrated that nurture physically alters the brain, and this supported the importance of stimulation in learning and development. Okay, study number 3. Are you a natural? Boucard et al., 1990. The reason this study was done was to assess the relative influence of genetics versus environment on psychological traits. For their hypothesis, they thought that twins reared apart would still somehow show strong similarities due to a strong genetic influence. For their methods, the Minnesota twin study, they examined identical and fraternal twins separated at birth. They compared IQ, personality, interests, and habits. In the end, the identical twins reared apart showed striking similarities in intelligence and personality. And while genetic factors accounted for a significant portion of differences, their environment also mattered. Something interesting about this case is it sparked some ethical questions about adoption and genetic testing. Okay, last one. Watch out for the visual cliff. Gibson and Walk, 1960. The reason the study was done was to determine whether depth perception is learned or an innate trait. Their hypothesis was that if depth perception is innate, infants and young animals would avoid crossing a visual cliff. The way they tested this was that they built a table with a solid glass top, one side with a shallow surface, the other appealing to drop off, quotes, the cliff, and they tested it on human infants and young animals to see if they would cross. Most infants and animals refused to cross the cliff. This suggests that depth perception is inborn or innate and not learned. This is significant because it provided strong evidence for the perceptual abilities of animals and humans being biologically hardwired. Well, how does this apply to the real world? Well, the first study, One Brain or Two, helped improve treatment and rehabilitation strategies for patients with brain surgeries or patients that just came out of surgery. As for education, it showed that certain cognitive tasks may benefit from hemisphere-specific training, for example, language or spatial skills. For the second study in education, it supported the development of enriched learning environments for children. In therapy, they informed rehabilitation practices for patients recovering from brain damage or strokes. For the third study, had some advances in counseling and psychology. They helped counselors recognize the strong genetic component of personality and intelligence when advising clients. Uh, in medicine and education, they encouraged more individualized approaches to mental health and learning, balancing genetic predispositions with environmental influence. And the last one made some strides in with parenting and education, reinforced the idea that perceptual abilities like depth perception are largely innate, reducing emphasis on overprotective teaching in infancy. In safety and design, this study influenced approaches to child safety because infants already possess depth awareness that guides cautious movement.